Hi everyone, today we are going to learn 9.2 higher order constant coefficient homogeneous equation. Okay, so 9.1 previously we learned the linear higher order equation, right? So nth order differential equation, yeah? So we have y to the n derivative and then piece of 1x, y to the reduced by 1 derivative, right? And so on. Then piece of n x, y, right? And then other side we have the function. Okay, then homogeneous equation, so other side must be 0, right? Okay, now if we have a constant coefficient equation like the title, right? So 9.2 title has constant coefficient, right? Okay, then we called S sub 0, S sub 1, everything is a constant coefficient, right? And then other side equal to 0, that's a homogeneous equation, right? Okay, then previously we have characteristic polynomial, right? Okay, so P of R, and we have this form, right? Then we need to find the root, right? That's why I think that's why they put the R from the root. Yeah, root means a solution, right? So this note from section 5.2. Yeah, so we did that, and then we are using maybe two previous section. We are using this one too, right? Yeah. Okay, so let's review a little bit. We have three cases, right, from the characteristic polynomials. So we have a second order linear equation, homogeneous equation, right? Then case one, we have a distinct real root, means the only one root, right? Okay, then, sorry, not the only one root, distinct real root, yeah. Then there is R sub 1, R sub 2, right? Okay, now there is only one root, has repeated roots. Since this is a second order, there must have two roots, right? But then in the two roots, one is a repeat, right? Okay. Now, in that case, we are using general solution, this form. First one, two roots. Then we are using this format. And third case, complex conjugate, right? Yeah. And then the first format is like that. And basically, our two roots will be lambda plus minus I omega, right? Okay, then we writing general solution, this format, right? Yeah. How they find the lambda, how they find the omega there, right? So, in that case, inside the square root, we get the greater than the 0, right? In that case, exactly same as 0. In that case, the inside the square root, we called discriminant, right? Yeah, inside the square root. So inside the square root is less than 0. There is two conjugate roots, right? Yeah, make sense? Okay. This is a review from 5.2. So let us do this question. Yeah. So solve. Aha. In that case, it's not the second linear second order. This is a third order. Yeah. Can you see that? Triple. Yeah. So derivative third time, minus 6y second prime, 11y prime, minus 6y equal to 0. Okay, now we have initial value problems, right? And then this one we can change to characteristic polynomial, right? So there will be r to the third power instead of r squared. We did that before, right? Negative 6r squared plus 11r minus 6 equal to 0, right? Okay, so before, if we don't have third power, we can just using factoring out or using quadratic formula, right? Okay, well, in that case, third, so we can use just technology, right? We don't want to waste a lot of time for finding root, right? So, okay, so tip, use Desmos graphing calculator. So look, we have this one. This is the tip, right? Okay, now we can see that there is 3 zeros, means that 3 roots, right? So everything in the case is real numbers, yeah? 1, 2, 3. Yeah, good numbers, 1, 2, 3, right? Okay, so this one we can express r plus 1. Wait a minute. The root is 1, so minus 1 is, right? Minus 1. And root is 2, so r minus 2. Root is 3, so r minus 3, right? So with this is equal to 0. Then what's the r? R. It's 1, 2, 3, yeah? Nice number. Okay, then case number 1, right? Case number 1, we have that general solution, this form, but we have another solution. So we just add third term, right? So general solution, yeah. Okay, so then we add c sub 3 e to the r sub 3 x. Okay, then in the case, r sub 1 equal to 1, r sub 2 equal to 2, r sub 3 equal to 3, right? So there will be c sub 1 e to the 1 times x plus c sub 2 e to the r sub 2, which is 2x, plus c sub 3 e to the r sub 3, which is 3x. Make sense? Yeah, that's the y, yeah? Okay, we're done, right? But then we have initial value problems. So we want to answer that, right? To find particular solution. Yeah. So let us do that. Okay, so I want to use this one. Copy. Yeah. All right, so y prime. So y prime, same c sub 1 e to the x power plus, right? And y second term, second term, c sub 2 e to the 2x times 2, right? And plus third term, c sub 3 e to the 3x times 3, right? Okay, y second prime. So same, right? And then c sub 2 e to the 2x and times 2, so it's a 4 plus 6 sub 3 e to the 3x times the 3, so it's 9, right? Okay, now we're using that, right? So we're using let me using this one. Now use. So y sub 0 equal to 4, that means x equal to 0, right? So this is x equal to 0. Yeah. Okay. So when x equal to 0, then y equal to, right? So we have y equal to copy. So y over 0, right? So y over 0 equal to, no, we're using just y. Hold on 1 second. Y equal to, all right, so let me erase. Okay, so y over 0. All right, so 6 of 1 e to the 0, 6 of 2 e to the 0 plus 6 of 3 e to the 0, which is 6 of 1 plus 6 of 2 plus 6 of 3, and it's a 4, right? So it's a 4. Okay, now what about the y prime, right? So y prime of 0, 6 of 1 e to the 0 plus 2 6 of 1, 6 of 2 e to the 0 plus 3 6 of 3 e to the 0. So there will be 6 of 1 plus 2 6 of 2 plus 3 6 of 3 equal to y prime of 0 equal to 5. Okay, now y second prime of 0. So we have a 6 of 1 e to the 0 power 4, 6 of 2 e to the 0 power plus 9, 6 of 3 e to the 0 power, which is 6 of 1 plus 4, 6 of 2 plus 9, 6 of 3 equal to y double prime is the 9. So we get the 9. Yeah, good. All right, now we can use decimals. So let me show you decimals, matrix decimals. Oh my gosh. Where is, okay. Matrix calculator. Okay, A equal to, I click the new matrix and then 3 by 3, right? So row and column, 3 by 3. Oh yeah, we have to have another column 4, 5, 9, right? So another column, so 4. Yeah. So 1, 1, 1. That's the y, and then it's a 4, and 1, 2, 1, 2, and 3, and 5. Yeah. And 1, 4, yeah, correct, 4. 4 and 9 and 9. Yeah, it's 9. Okay, now enter, and then if we enter, there's a RREF, we use the row echelon form of A, Okay, then there is a solution. Yeah. Okay. Okay, so we get this. All right, so system 1 equal to 4, system 2 equal to, that means, right? So, yeah, oops. System 1 equal to 4, system 2 equal to -1, system 3 equal to 1, right? Okay, so we had the general solution like that, right? Ooh, copy? Yeah. So system 1, which is 4, system 2, -1, and system 3, it's 1. We don't have to, right? So, yeah, we don't have to write down 1. So, okay, so there will be e to the x minus e to the 2x plus e to the -3x. Yeah, that's the particular solution, right? Is it good? All right. So we understood? Okay, let's do next question. So same processing. All right. So we have solved that, right? So we convert to the characteristic polynomial. So it will be r to the third power plus 13 r squared plus 55 or plus 75 or equal to 0. Yeah. Okay, now we using technology Desmos. So we have this graph. Okay, now we have -5, ooh, and then -3 there, right? But then we knew that there is a third one because r cubed, right? Okay, then how do we determine, right? So look, this will be r plus 5 and r plus 3 because the root is, if we find the root, there will be r equal to -5 and -3, right? So they have -5, -3, right? Okay, so take a look the graph, right? So this graph just touched x-axis, right? But then this graph, and then look, then touched, come back, and then crosses on x equal to -3, right? Okay, so from pre-calculus, we learned that if even number of multiplicity, then the graph just touched. Yeah. So when I taught the pre-calculus, I said even touch. So ET, do you know the movie ET like that? Yeah. Okay, ET. So even number of multiplicity touches, the graph touches x-axis. Then odd number of multiplicity, the graph crosses x-axis. Yeah. Okay, so even number. So even number, we have a second power in that case, so that we can make 3 zeros. Is it clear to you? So even means 2 in that case. Yeah. Okay, so I have a note here, so let me bring up here. So where is? Yeah, there we go. All right. Okay, then let's take a look. If we have a repeating, so if we have a repeating root, then we are using this one, right? So once again, we have a general solution, but we have another solution too, right? Yeah. So another solution, we just using other format. Hold on 1 second. This is the one. Okay, so yeah, note. All right, so this is a repeating, right? So we say that this is also 1 equal to -5. Repeat. Yeah, repeat the root. Yeah, so there will be e to the -5x, and then 6 of 1 plus 6 of 2x. Yeah, if we distribute, then we get 6 of 1 e to the -5x plus 6 of 2x. Yeah. Oh, e to the, I did not write that. E to the -5x too. Yeah, I did not write down. Okay, now, what about the other solution? How do we write, right? So, because this is a regular solution, it's not the repeat. So let's make other solutions. So we have r sub 2 equal to -3 as well, right? So we have that. Then we express this one, c sub, since we are using c sub 1, c sub 2 in the previously, so let's using c sub 3 equal to, not equal to, I'm crazy. Y equal to c sub 3, y equal to c sub 3, e to the -3x. Yeah. Okay, let me double check. Okay, so now let's, yeah, then let's make this general solution. So y equal to, copy this one. And plus this one. Yeah, this is a form from the, what's called the real solution. Yeah, so one term. Yeah. Okay, now y prime. Look, hold on 1 second. I need to bring the initial value, right? that, copy. All right, so y prime, hold on 1 second before that, y over 0, right? So x equal to 0. So we have this one. Just looking at this one. Yeah, I don't have to bring down. So let x equal to 0. Then y over 0. 0 equal to 6 of 1 e to the 0 power plus 6 of 2 x is 0. Oh, then everything is 0, right? And 6 of 3 e to the 0 power. So that will be, I want to make a little bit smaller. Hey, come on. Come on. All right, hold on 1 second. Oh, shit. Okay. Okay, I did. I'm a very nice person. All right, so there will be what is? It's a 5. Yeah, it's a 5. Okay, then this is 0, right? Y prime. So let us do that. Y prime equal to 6 of 1 e to the negative 5x, and then multiply by negative 5 plus 6 of 2. Oh, this is the product rule, right? So let's see. Product rule. So f g equal to f prime g plus f g prime, right? So we will get f prime, which is 6 of 2, and g, which is e to the negative 5x, plus f 6 of 2x, g prime, which is negative 5, and e to the negative 5x, yeah? Please correct me if I make a mistake. And the last term, plus 6 of 3 e to the negative 3x times the negative 3, yeah? Okay, so let's arrange to negative 5x and plus 6 of 2 e to the negative 5x and negative 5 6 of 2x e to the negative 5x, negative 3 6 of 3 e to the negative 3x, yeah? That's a y prime. Okay, I hope I don't make a mistake. Okay, now let us do that. We apply initial value x equal to 0. So shall we do everything y second prime then apply later? We can do that, right? Yeah, because I did it here. So maybe we can change this one later. Okay, y second prime, because I need to see this y. Okay, we have negative 5 6 of 1 and negative another 5 and e to the negative 5x plus 6 of 2 negative 5 6 of 2 e to the negative 5x. Okay, product rule again. So this is f g equal to f prime g plus f g prime. So plus, let us do that. Negative 5 6 of 2 e to the negative 5x. That's f prime g and plus f negative 5 6 of 2 e to the negative 5x Hold on 1 second. Let me clarify this one. F of prime, so F of prime, yeah. Okay, we did a G, correct, right? And then F, we rewrite this one, G prime, this one, and -5 times, right? So -5, c sub 2x, e to the -5x, then -5, yeah. Okay, the last term, negative, positive, -3, c sub 3, e to the -3x, and -3 times 3, yeah? That's the last term. Okay, so all together, positive 25, c sub 1. Am I recording? Okay, scared. E to the -5x minus 5 c sub 2 e to the -5x and -5 c sub 2 e to the -5x and positive 25 c sub 2x e to the -5x, positive 9 c sub 3 e to the -3x, yeah? Okay. Is it combining like term? C sub 2, yeah? So we combine like term, this will be, right? That's it? Oh, no, here too. -10 plus 25. -10 plus 25. Positive 15. Yeah? Okay. So let's do it. 25 c sub 1 e to the -5x plus 15 c sub 2x. No, it's not. Sorry about that. That's not like term. Good. So only this one like term, right? Okay, so there will be -10 then, -10 c sub 2 e to the -5x, yeah? And plus 25 c sub 2x e to the -5x plus 9 c sub 3 e to the -3x. Yeah. That's the y second prime. Okay, now we're using initial value problem, right? So initial. So we have, I'm gonna copy everything here. Copy. And here. Oh no, I have to cut, not to copy. I have to cut. Cut. Yeah. All right. Okay, now y prime, yeah, y prime. So y prime, let me see. C sub 1, C sub 2. Okay, so y prime of 0, look, equal to -5 c sub 1 e to the 0, right? Plus c sub 2 e to the 0 power. And the next one is 0 minus 3 c sub 3 e to the -3, oh, 0. Yeah, sorry. Equal to, what do you get? Well, we have y prime is -19. Okay, now y second prime of 0. Okay, the last one, 25 is 1 e to the 0 power minus 10 is 2 e to the 0 power and plus 0 plus 9 is 3 e to the 0 power. What do you get? 73. So we get 73. Okay, now rewriting everything nicely. So we have a sys of 1 plus a sys of 3 equal to 5. We have a negative 5 sys of 1 plus a sys of 2 minus a sys of 3 equal to negative 19. And we have 25 sys of 1 minus 10 sys of 2 plus 9 sys of 3 equal to 73. Yeah, we can use decimals. Then what do you get? 25 sys of 1. Okay, so if we are using decimals matrix, decimals matrix calculator. So we have a sys of 1 equal to 2, sys of 2 equal to 3, sys of 3 equal to 2. Then particular solution will be, we have, so from general solution, right? Let me copy. So like here, general solution. And let me erase this one later. And particular solution will be y equal to c sub 1, which is 2 e to the negative 5x plus c sub 2, which is 3x e to the negative 5x plus c sub 3, which is 2 and e to the negative 3x. Yeah? Okay, let me double check this one because I changed C sub 1, C sub 2, C sub 3 here. Okay, let me double check. Let me pause. Okay, so I brought the decimals here, decimals matrix. So look, slightly different because this is a C sub 1 equal to 3, right? This is a C sub 2 equal to 2. This is a C sub 3 equal to 2. So it should be changed, right? So 3 to 2, 3 to 2, right? 3 to 2. So there will be 3 to 2. That is the particular solution. Yeah, make sense? Okay. Now let us do last question. So we did that 2 cases, right? So one, the last case. Yeah. All right. So let's take a look. So we have y triple prime, negative 6, y double prime, positive 34, y prime, minus 104, y equal to 0, right? Okay, with the initial value problem, right? Okay, so let us rewrite it with characteristic polynomial. Yeah, so we can guessing in that case complex solution right. So okay, so we have r to the third power minus 6 r square plus 34 r minus 104 equal to 0, right? Okay, now looking at the decimals, yeah, it's not like this, right? Cube root, right? So cube root looks like that or looks like that, right? Okay. This one, there is only one solution for the real number, yeah, which is F4. Okay, so that means we have R, and then the root has a 4, so -4. Okay, then how do we find the rest, right? Yeah, we are using synthetic division. So let's do it. So use 4 for synthetic division method, right? Okay, so we take the only coefficient, right? So +1, -6, +34, -104, right? So we have to have a descending order. So must be descending order. Okay, so we have, oops. 1, -6, +34, -104, and, oh, I cannot make nicer. Okay, like that. Okay. All right. So using 4. Okay. So the synthetic division, there's a rule. We always bring down the first one, right? Always bring down. So we have 1, and we multiply. So it's a 4, right? Okay, then we add. So -2 and multiply -8, then +26, multiply 4 times 26, we get 104, then it's 0. Yeah, now how do we arrange, right? So 0 means it's a remainder. There's no remainder. And then after remainder, we have a constant term, right? Constant term. And then degree 1, right? X, like that, right? And degree 2, like a squared, x squared, right? And third, fourth, right? Yeah, like this. Okay, so in that case, we can use that x squared, 1 times x squared, right? And -2 x degree 1, right? And plus 26 constant term. Yeah. Okay. Now, I told you, I gave you a hint, right? That will be complex. And then we see that in the decimals, there's one real number solution. Yeah. Then there's another 2 solutions, roots. Then there will be complex. Yeah. So it's a case number 3, right? So case number 3. Do I have one here? Case number 3? Okay, I have one. Case number 3. So we have a case number 3. All right, so let me make a little big special, yeah, box. So we can see that, right? All right. Now, lambda equal to negative b over 2a, right? So let us, using the formula, so lambda equals to negative b over 2a, And there is A, B, C. A equal to 1, B equal to -2, C equal to 26. So negative 2 over 2A, that will be 2 over 2 is the 1, right? Okay. Now, omega equal to square root of 4AC minus B squared over 2A. So that will be square root 4 times 8 times C 26 minus B squared, -2 squared over 2A. Okay, can you please calculate? This will be 5. Yeah. Okay. So for a complex root, so this is the complex root, general solution. So general solution. So y equal to e to the lambda, which is 1, right? Which is 1. And then x, we don't have to write down. And c sub 1 cosine omega, which is 5x, plus c sub 2 sine omega, which is 5x. Yeah. Okay. Oh, I see. Uh, you know what? C sub 1 we were using. Oh, I did not use. Okay. Uh, so since we found this one earlier, right? So R sub 1 equal to 4. So just a real number solution, we can express y equal to C sub 1 e to the 4x, right? Yeah, we can express from the real number solution. Yeah, just one term we are using that, right? Yeah. Okay, C sub 1 e to the 4x. Then we are using this one, C sub 2 and C sub 3, right? C sub 2, C sub 3. Okay, now then general solution will be, this is not general solution, so general solution will be y equal to the earlier one. What was it? 3? I don't remember. Okay, so C sub 1 e to the 4x. Yeah, C sub 1 e to the 4x. And then we distribute. So we have C sub 2 e to the x cosine 5x because we're going to find derivative later, right? That's why I want to distribute, right? So C sub 1, I'm sorry, C sub 3 e to the x sine 5x. That is a general solution. Okay? All right, we almost done. Now, initial value, right? So initial value, we are using that. Yeah, maybe we can use this one later, right? So copy. Maybe here. Okay, now, y prime. Yeah, y prime. Oh, it'll be messy. Okay, y prime. Y prime. Okay, the first term, 4x is the 1 e to the 4x, yeah? Second term, it's ooh, product rule. Okay, so there will be f prime plus c sub 2 e to the x and g plus f g prime 5 cosine 5x, yeah? Okay, now product rule again. So that will be, oh no, derivative of cosine 5x. We've been doing this e to the x, yeah, that's why, sorry. So derivative of cosine 5x, negative sine 5x, right? So negative sine 5x and times 5. Okay, now f prime, so c sub 3 to the x, g, and let me make a little bit smaller. And f g prime, derivative of sine, cosine 5x and times 5. So 5 cosine 5x. Yeah, cannot make that one line. All right. Now, can we combine? 2, 2, 3, 3. No, we cannot combine, right? So 1, 2, 3, 4, 5 term. 1, 2, 3, 4, 5 term. Okay. All right. So y second prime. First term, 16, c sub 1 e to the 4x plus, okay, so fg equal to f prime g plus f g prime. So that will be c sub 2 e to the x cosine 5x plus f, which is the c sub 2 e to the x, g prime, which is negative sine 5x times 5, right? Okay, we finished that. Okay, now we are doing this one. It's negative. So there will be negative 5 c sub 2 e to the x sine 5x, yeah? Okay, so once again, product rule. So FG, I don't have to write down, right? So we knew that. Okay, so there will be plus and negative, oh, different colors. So plus negative 5 c sub 2 e to the x and sine 5x and plus f, then g prime. So 5 cosine 5x. That's the g prime, right? Okay, now we are doing this. Okay, so that will be plus f prime c sub 3 e to the x and g plus and c sub 3 e to the x 5 cosine 5x, yeah? Okay, last term, yeah. Do we have a third prime? No, okay, good. All right, so last term, so we have c sub 3 to the x, 5, yeah, and then cosine 5x, plus and negative 25 c sub 3 e to the x sine 5x, yeah? Okay, please correct me if I make mistake. All right. Everything is good? Okay, so can you combine? Let's see. C sub 2, C sub 2. Yeah. Let's see. C sub 2. C sub 2, 5, and 1. Okay, so this one, same, right? Combine, we can combine. Okay, so let's make that 16 c sub 1 e to the 4x. And then yellow one, we have negative 25 plus 1. So negative 24 e to the x cosine 5x. That's the yellow one. Yeah. Okay, now let me see. C sub 2 sine. Yeah, C sub 2 sine. C sub 2 sine. This one, C sub 2 sine. C sub 2 sine. C sub 2. Okay, that's it, right? C sub 2 sine. No. All right. So there will be negative 4 then. Oh, no. Negative 5, negative 10. Yeah, can you see? So it's a negative 10. And e to the x sine 5x. So we have a negative 5 there, and negative 5 is a negative 10. So that will be green. Yeah. Okay. Now let's see. And C sub 3. C sub 3 sine. Okay, this one. And the last term. So negative 25, my positive 1, also negative 24. So negative 24, c sub 3, e to the x sine 5x. So that will be the orange color one. Okay, now everything I will rewrite. Yeah, so there will be positive c sub 3 e to the x. There is a 5 cosine 5x. Okay, hold on. So I am rewriting this one. Plus 5 c sub 3 e to the x cosine 5x. Okay, so, oh no, it's same, isn't it? Let me double check. This is, this is same as this, right? So we can combine in positive 10 then, right? Okay, so let's make a different color. Yeah, no, make it like that. So it's a positive 10 c sub 3 e to the x cosine 5x. So that will be 1. Yeah. Okay. So you guys okay with this? Now we are using initial value problems here. Okay, so let me copy only the general solution, right? Otherwise too long. Copy. All right. So when x equal to 0, y of 0 equal to 6 of 1 plus cosine 0 equal to 1, right? So 6 of, hold on 1 second. um, yeah, right? So cosine 0 equal to 1. Sine 0 is 0, right? Okay. Okay, good. So 6 of 2, I want to make sure because I don't want to give it to you wrong information and easily to make a mistake too, right? Okay. So there will be 6 of 3 equal to 0. So we have equal to 3, right? Okay, y prime over 0. Okay, looking at there. Let's looking at that. All right, so 4 6 of 1. Cosine 0 equal to 1. So plus 6 of 2. And third term, sine 0 is 0. And another term, sine 0 is 0. And the next, last term will be 6 of 3, right? Equal to, it's a 4. Yeah. Okay. Now, y second prime of 0, 16, 6 of 1. Cosine 0 is 1, negative 24. Wait a minute. We're missing, uh, I'm missing not 6 of 2 here, right? So I'm missing 6 of 2. So let me write down 6 of 2 there. And 10 e to the x power. Also 6 of 2 is missing there, right? And then 6 of 3 there, right? Okay, now 24, 6 of 2. And this is 0. And this is 0. We have 10 6 of 3, right? 10 6 of 3 equal to negative 2, right? Okay. All right. So if we are using decimals, matrix. So we get 6 of 1 equal to 2, 6 of 2 equal to 1, 6 of 3 equal to negative 1. So from general solution, let me copy this one here. Copy here. Okay, so there will be 6 of 1, we have 2 e to the 4x plus 6 of 2, 1. So we don't have to write down cosine 5x minus 1, so negative 6 of 3 is negative 1, so e to the x sine 5x. That is a particular solution. Yeah, so thank you for watching. Bye.